Hello, everybody. So who I am? I am Anne. I am deeply passionate about blockchain technology, and I'm currently working as a Web3 developer and researcher at Evenness. I'm currently in charge of shaping the Web3 and blockchain strategy for our two platforms. Furthermore, I'm also working on the design of the tokenomics business model for both of these platforms. And I'm also a part of the organizing team of the Brussels Blockchain Week that takes place every year in June. This is the table of contents. So today I'm going to walk you through 4 points. So the first one is what is blockchain, is smart contracts. Then we'll deep dive into decentralized application architecture. And we will finish discussing blockchain and AI and why we need a verifiable and trusted web. So what is blockchain? So when you think about blockchain, you have to think about backend technology because blockchain is a backend technology. And when you think about blockchain, you have to think about trust because blockchain is actually replacing trust. So which means that when you have an untrusted environment, you can use blockchain to replace trusted intermediaries. And by trusted intermediaries, you can imagine that you would be able to replace a bank by blockchain, or you would be able to replace a government, or you would be able to replace Airbnbs and directly be able to book a room or an apartment for a city trip directly to a user, not using the Airbnb platform to book your room. So how it works? So what you have to know is that blockchain is actually a database that is distributed nodes, and it is called distributed ledger technology. So every node in the network holds a copy of the blockchain or of the distributed ledger technology. And also what you have to know about blockchain is that blockchain is all about transactions. So when you think about blockchain, you have to think about trust, transactions, nodes, those kind of things. So and thanks to blockchain, so as I said before, you can perform peer-to-peer transactions, which means that instead of having a trusted intermediary like a bank, like a government, or like Airbnb or Uber, you will directly be able to make your transaction peer-to-peer. So the data that is contained in this distributed database is stored in blocks, and that is why the technology is called blockchain. So blockchain, you can think of a chain of blocks. So to add a new block to the chain, all the nodes in the network, they have to come to a consensus to determine which copy of the blockchain is the right one or not. What you've also to know about blockchain is that they are almost impossible to hack, as all the node in the network has to come to a consensus to validate and add a block and so the transactions. It is also very secure, also because of the cryptography that is used for every block in the chain, because every block in the chain contains the hash of the previous block, and because it contains the hash of the previous block, it makes actually as if you want to tamper with one block and change the transaction in one block, all the other hashes that are contained in the other blocks are going to change. Also, another things that you have to know is that the more decentralized the blockchain, it is hard. So the harder it is to hack it. So it means that the more nodes in the networks, the more it is difficult to attack the networks. So as an example, 20 nodes is easier to hack than 10,000 nodes. And if I can give you an example, so to give you maybe an idea, so Solana is a very it's not a really decentralized network because there are only, I think, like 50. There are less than 100 nodes, whereas Bitcoin you have more than 10,000 nodes. So that's why Bitcoin is actually very difficult to hack. So now I'm going to walk you through smart contracts. So when you think about smart contracts, you have first to think about Ethereum. So Ethereum is actually a layer 1, and it is a layer 1 where you can build on the top of it. So to understand how a smart contract operates on a blockchain, this is what you have to understand. Smart contracts are written code and contains predefined rules and conditions that automate and enforce the terms of an agreement between parties. The smart contracts, they are deployed onto the blockchain, so you can build smart contracts on the Ethereum blockchain, and they are stored in a tamper-proofed and transparent manner. When specific conditions are met, so the smart contract is able to automatically execute. So as said earlier, because it is on a blockchain, the smart contracts operate on a decentralized network of nodes. And because it is decentralized, it ensures trust and security. Also, something that you have to know that is very specific to smart contracts is that when smart contracts are deployed, they cannot be changed. So they cannot be altered or manipulated without the consensus of the network. So smart contracts are actually what allow blockchain to eliminate the needs of intermediaries. So as I said before, it can, instead of having a bank or Airbnb or Uber, you will just have a piece of code that is written and that will automatically execute. So also what you have to know is all contract actions and outcomes are recorded onto the blockchain. And because everything is recorded on the blockchain, it provides transparency and auditability. So now I'm going to walk you through the architecture of a decentralized application. A decentralized application is an application that runs on a decentralized network. So unlike traditional applications that relies on centralized servers, a decentralized application is built on decentralized technology. And what you have to know is also that it can be fully decentralized or semi-decentralized. So it can be partly or entirely built on decentralized technology. So as you can see here, the architecture of a full-stack decentralized application consists of the front end, so the hosting for the front end, a wallet component, the smart contracts, an access to nodes, the data storage, and also other potential components like indexers and oracles eventually. So here I'm going to talk more about the components that are in the front end. So the front end is what you can see. So here on the front end, so the front end is actually the client. So the front end is the user interface of a decentralized application, and the technologies that are used to build the front end of the decentralized application are actually the same as the technology that are used to build a normal application in Web 2. So those technologies are HTML, CSS, JavaScript. You can use JavaScript front end like React, Next.js, or Angular to make your website more dynamic. So the good news is, if you're a front end developer, if you want to make your transition to Web3, everything that you know so far will actually stay. So it's not going to change, because the front end part is not going to change, because as I said earlier, blockchain is a backend technology. It is to store data. So a thing that you need in your front-end code to be able to communicate to the blockchain is actually a connection to a node. So in your JavaScript code in the front end, you have to use a JavaScript library that will make the connection to this node. So there are different types of JavaScript libraries, but the most The most famous are actually Web3.js and Ethers.js, and they allow to make this bridge between the front end and the back end. What you also have to know, because you have to communicate with one of the nodes of the blockchain network, is that you have to use a node provider. So there are a lot of a lot of node providers that are very well known, like Alchemy, QuickNode, or Infura. What you can also do is to run your node yourself, but most of the developers, they just don't do that because it takes a lot of time. So they prefer to use a node provider like Alchemy or Infura. So the hosting part here. So the hosting is actually when you use an online service that essentially allow developers to publish the file of your web application. So it can be a Web2 or Web3 application. It doesn't change anything. And as an example, so one of the you could use AWS because it's one of the most famous hosting provider. But if you really want to make this application fully decentralized, what you can do is also use a decentralized system like IPFS or Filecoin. So a component that you also have to implement in your front end is it's the wallet, because in most of the decentralized application you always have a connect wallet button. So you have to click on this connect wallet button to be able to allow the application to connect with your wallet, where you will have all your digital assets, when you will be able to sign transaction on the blockchain, and where you will be actually authentified as a user. What you also have to know is in the context of a decentralized application, you have two types of wallets: the custodial wallet and the non-custodial wallet. So the custodial wallets are managed by third-party service providers, such as exchanges like Coinbase or wallet services. And the non-custodial wallet is actually a wallet where the users are in control of their key. So MetaMask is a wallet that is located on your browser, and you can make the connection with the decentralized application via MetaMask. And MetaMask is a non-custodial wallet, which means that with MetaMask, you will always remain in control of your key. So now I'm going to walk you through what you don't see in a decentralized application. So maybe the most interesting part in a decentralized application, for your application to be able to connect with the blockchain, you have to connect with a node. So a node is actually an individual server that is a part of the blockchain and participate in the blockchain. And this node will validate and relay a transaction to the network. To make this connection with this node, you will actually need to use a node provider. So what you will do is actually to use internet services and node provider like Alchemy or QuickNode or Infura, so that you don't have to maintain your own infrastructure. An interesting thing to know is that nodes, most of the time, they support two types of operations on the blockchain. So you can read from the blockchain, or you can write operation onto the blockchain. When you read from the blockchain, it means that you can read the data on the blockchain, and this doesn't cost any gas fee. But when you want to write operation on the blockchain, so when you want to change the data on the blockchain, it will cost you a gas fee and you will need to pay. So another part of the backend of a decentralized application is the smart contract. So the smart contracts, so I've already explained earlier what was a smart contract, so I'm going to go quick on that part. But what you have to know is that it can be written in different types of programming languages like Solidity, Rust, or or Viper. The smart contracts are written in Solidity. And once a smart contract is deployed, of course, you cannot change the code. So that's for the theory. So that when a smart contract is deployed, you can never change the smart contract itself. But what you can do, I'm not going into the detail, you can actually upgrade your smart contract by deploying another smart contract. So there are some tricks where you can actually almost reverse what you have done. Decentralized architecture is the indexing solutions. So an indexing solution is actually making the blockchain data more accessible and queryable. So indexing solutions are all about querying, be able to query the data on the blockchain. So query solutions are also used because blockchains, on a blockchain you can have a lot of data and it can be very complex. So sometimes you actually need a technology layer between the smart contracts and the front end to actually be able to translate those data and to put those data into categories so that it will be easier to query the data and get access to those data. So that's what indexing solutions are for. So the most known indexing solution is the Graph, which is a decentralized indexing protocol. And with the Graph, you can actually develop some subgraph. And when you have developed some subgraph, you have all your data that are very well organized so that it becomes really easy to look at your data and be able to tell, okay, those data belongs to that category, those other data, they are all in that category, those kind of things. For the data storage, so as I said earlier, you can actually use a centralized type of data storage, which is a database like MongoDB or Postgres SQL, or you can also use a decentralized type of storage, which is Filecoin or IPFS. I just want also to mention that what you store on the blockchain is actually, most of the time, it is the minimum. And most of the time what you have is that on the blockchain, you will store a hash, you will store the hash, and this hash will actually be the reference to your IPFS file. So on the blockchain, you always try to you always have to store the minimum of data because of the computation, because every time you run your contract, you have to pay something. That's why on the blockchain you will store the minimum that you can do, and what you will store is most of the time it's a hash, so that once you have the hash, you can see on IPFS what is the content, what is the full content of the. So the last component of the decentralized architecture I want to discuss is the oracle. So the smart contracts, normally they execute predefined logic based on the information available within the blockchain network. However, what happens sometimes, in a lot of cases actually, is that you need data from external sources. So if you want to work with weather data or stock prices data or sport scores data, so data that are changing over time, you will need to incorporate those data that are always changing into your smart contracts. And therefore, to be sure that you have the right type of data, you will need to compare, to go off chain. And Oracle, it is an entity that provides a way for the decentralized Web3 ecosystem to access existing data source on the Web2 part. So that's what oracles are for. It is a very important technology because they actually bring off-chain data on-chain. So this is really a technology of the future. And the most popular decentralized oracle is chaining. It's also a very well-known technology. So right now, I'm going to walk you through blockchain and AI. and also the necessity of having a very rapid internet. In the future, what you have to know is that AI and blockchain, they will actually coexist with each other. And especially we will need to coexist with a lot of AI. So what you have to know is that we will have a doctor AI, we will have a teacher AI, we will have a writer AI. And also, because of AI, everyone will get amplified. And the society that will exist in 10, 20 years will be very different than what we can experience now. So AI will actually offer us immense possibilities. The point of failure of AI is the provenance of the data. And that's why we really need this trusted and verified web, because around the internet, we have no clue about the provenance of the data. So at some point, what will happen is that a trusted and verifiable web will have to be created, and it will be created maybe by government or by social media. Let's say the government or social media, they will have to figure out how to know where the data came from. So they will have to figure out how to know where the data came from, who the author was, and how we give this author credit. So in the future, we will actually be constantly notified when the data is human generated or when a data is computer generated. Because so far we have built a web without having an accurate sense of identity, because also it was not really needed. But now with the rise of AI, as you can see, we see a lot of deepfakes. When we see a video, we cannot really tell if those individuals exist or not, if their voice is correct or not. So we are really exposed to a lot of misinformation, and we don't really know where is the reality. So that's really important to be able to certify who is who. And also for yourself in the future, with the internet, you will also need to be able to certify, okay, I certify that I am Anne and that I'm not an AI. So what is in development nowadays is digital identity. How you can actually put your digital identity on the blockchain and certify that you are that person, that it is. And actually, the thing is that, okay, maybe in Belgium I can trust my government, but in other parts of the world, people, they don't really trust their governments. So it is also important that individuals are able to self-certify their identity without the need of a government. So here an example where it is really important to be able to certify who you are and to be able to tell the difference between a content that is human generated or computer generated is the example of election. So AI has actually the potential to mislead campaign election. And if you remember, it was 8 years ago, so almost 8 years ago in 2016. So Cambridge Analytica managed to manipulate the Brexit referendum, and what they targeted citizens with messages and adverts on social media, and then those citizens were influenced to vote in favor of Brexit. And now we are in 2023, and next year in 2024, we'll have 50 elections everywhere in the world. So we'll have elections in the US, we'll have elections in India, we'll have elections in Belgium, my country also. And honestly, chances are that it will be really messy, because if you look back at 2016 and now, in 8 years' time, AI has made a lot of progress. So the possibilities to influence elections are actually much more bigger right now than 8 years ago. And I thank you for your attention, and yeah, don't hesitate to connect with me on LinkedIn.
Front end as it is will remain more or less similar, but the data will be stored differently, not on single server, but on multiple servers, etc., on the network of different devices. So from that perspective, you can utilize already existing templates for JavaScript front end, for example. One of those can be Next.js, or go to Vercel. I'll type in messages and find the templates from there, already existing, kind of ready to start with a few lines of code if you're already familiar with JavaScript in general, and you'll get even like video streaming template out of the box with different services where that data will be stored, or on the other side with the network of blockchain computers where everything can be stored and pulled from, etc. So that would be my 3 steps recommendation for the start.
Yeah, I'd like to jump back on what you just said, because you just talked about Vercel. Actually, if you want to start to develop on Ethereum and build your first decentralized application, it is good to go on Scaffoldis, because Scaffoldis is actually, so it's already a template where you would have a React interface. And with this template, you can actually play with your smart contract and those React components at the same time, and it is actually deployed on Vercel. So it makes me think of Scaffoldis. I'm going to put the link here on the chat here. So if you have a basic knowledge of programming and you want to play with smart contract, I would recommend to use a Scaffold here, because you already have this kind of setup, and you can deploy it with and host it on Vercel. You can host your application on Vercel, and you already have this React interface. So you just have to modify the backend and play with blockchain and smart contract.